Hi again, welcome to the third video on solving simultaneous linear equations in algebra. In this video we extend our algebraic techniques for obtaining solutions from the context of straightforward coefficients for the two variables to equation sets where the two variables all have different coefficients and no coefficient equals 1. An example of having unequal coefficients for the same variable is the following set. 2x minus 3y equals 4, 3x plus 2y equals minus 7. Solve these simultaneously. Now the coefficients of x are not the same across the two equations. Neither are the coefficients of y the same. We cannot therefore use our previous approaches directly. But if we make the coefficients of one of the variables the same, we create the same situation as for our previous techniques. It makes no difference to our result as to whether we equate the coefficients of x or the coefficients of y. You choose the variable you want to equate in each question as you come to it. In this case, we choose the coefficients of y. They have different signs, and because of that, I can easily add to eliminate the y terms. So to equate the y coefficients, we multiply all the terms in the first equation by 2, and that's going to create a minus 6y, and we multiply all the terms in the second equation by 3 to create a plus 6y. So we do that. 2 times 2x is 4x, minus 6y equals 2 times 4 is 8, and multiplying by 3 we have 9x plus 6y equals minus 21. So add the equations together, we get 13x, the y's cancel out, and minus 13 on the right hand side. So x is equal to minus 1. Substitute back into the second of the original equations because it's a bit easier. So minus 3 plus 2y equals minus 7. 2y is going to equal minus 4, y equals minus 2. So the solutions for this equation set are x equals minus 1 and y equals minus 2. Let's try another set. Minus 2x plus 3y equals minus 5. 5x minus 4y equals 9. Now we're going to equate the coefficients of x, and in order to do that, we're going to have to multiply equation 1 terms by 5, and we'll have to multiply equation 2 terms by 2. So let's do that. Minus 2 times 5 is minus 10x plus the 15y equals minus 5 times 5 is minus 25. The second equation, multiplying by 2, we have 10x minus 8y equals 18. We have reverse signs for the x terms, so we can add those nice and easily. So they cancel out. 15y minus 8y is 7y equals minus 7, dividing y equals minus 1. Substitute back into your second equation, again coincidentally, but it's just probably easier. We have 5x minus 4 times minus 1 is plus 4 equals 9. 5x equals 5, x equals 1, so the solutions are x equals 1 and y equals minus 1. So straightforward, so easy. Solving equations simultaneously requires strategies to merge the equations. We've dealt with some of those strategies in the previous video, and we've continued them in this video. So to add to your list that you've made at the end of the second video, we can say that if the format of the equations is such that all coefficients have different values, then the technique we're going to use is to multiply each equation by selected constants to equate the coefficients of one variable across the two equations. Hope you understand these techniques and when to use each. Thanks for watching this video. In the next video in the series, we look at algebraic methods for sets of 3 equations, as well as techniques required for solving sets involving nonlinear equations. Hit the like button and subscribe if you haven't already. Also, go and do some questions in the Advanced Simultaneous Equations Test Yourself 1 on my website at drjaysmaths.com. Add a comment below and send me an email if you have any questions. Good luck. See you later.